There's been a lot of talks about CPUs lately. Why? Well, I think mainly it has to do with these graphs. AMD spiking over the last couple of months, Intel spiking for the last couple of months. But then the question is like, well, why is that? Because it seems like CPUs are tied into two things. You have the GPU racks, where you have a CPU allocating work to the GPU. And like this part, it doesn't seem like it's going to be like a huge new increase. Like you have a 1:8 ratio or something like that today, where you have a lot of GPUs that is going to be needed, and the CPU just basically come there to do work to tell you what to do on the GPU. And in this place you have like a bit of inefficiencies, and there's optimizations that can be done here. There's also certain things that can be offloaded from the CPU to the GPU. For example, some PhD students in a Scandinavian university has tested at offloading tokenization from the CPU to the GPU and get like 100x type of improvement on the kind of like compute performance, on latency and all of that. So I'm not seeing like this demand could be driven per se by like a huge number of like new CPUs that's going to need it in the server racks. So what it has to be tied into is the thing that everyone is talking about today, which is agentic AI. And they are arguing for more specifically, a 1:8 CPU to GPU ratio going up towards a 1:1 ratio for CPU to GPU for inference workloads increase for CPU demand. And this to me boggles me. This is like something I could not, when I saw this, I could not get my head around why this could be such a big number. And why I'm feeling this way is because I work with these agentic AI side of things, where I'm building research workflows for financial institutions to basically do like financial research in as robust of a way possible. So in this area you have, for example, like tool calling. And within tool calling for like these agents is that you can have like API calls, you can have like bash commands, you can do like some data analysis, like manipulation, and all of this good stuff. But like these types of tasks, they're not resource intensive. Like I've been able to spin this up on like an EC2 instance on AWS for like less than 8 gigs of RAM, a little bit of CPU, and like a little bit of storage, and you're good to go. So this can't be the thing. Like even if you're running like some like Monte Carlo simulations, or like yeah, maybe if you're throwing in like a huge transformer forecasting model, but are you gonna let that be one shot by an agent? Maybe in the 2030s, who knows? But as of right now, like I can't see this being a big thing. So what should all of this kind of like connect to? And I think the answer is like what basically has been popping off over the last couple of months in the 2026, which is the coding agents. Because there is something about coding agents that does actually kind of add up to this argument about more CPUs. And that is the fact that, let's say you have only the PM. I am, seeing some feedback from a user that says that like, oh, I need like a button to create a new chat that is a bit more like easy to read. Okay, so like improve button to create new chat. Okay, cool. So then from here I go to my little Claude Code instance, but in this Claude Code instance I have now two options. Either I'm running this locally on my machine, so like what I'm doing today is like on my laptop, like a little dev laptop, or you spin this up into the cloud. Right now, like I'm a little bit of a boomer myself. I have usually like everything running on my local machine because I'm enjoying working on single tasks each time. I think the YC people prefer to do like, let's say like 20 different tasks and spin it up on the cloud. So maybe that's where it's going. I'll play with both scenarios here. I'll include like the boomers myself, and also like the new age YC founders as well that might spin it up on the cloud. But we tie it back to the actual feature improvement here of like, making this button a bit easier to read or something. What's going to happen is that like you need to have on this Claude Code instance, you need to have the code repository. Like, you need to be able to like see the code and traverse the code, and like, you know, the agent needs to like, you know, test things out. So first, of course, we'll split that up, reading stuff and then actually testing stuff. So in this case, you read and you test. And this is where the CPU arguments become a little bit more kind of like understandable from my view. I was skeptical at first when we just looked at this stuff over here, like the tool concept. I was like, this doesn't take any resources. What are we talking about? But if we're looking at companies like Lovable and all of this trend to basically like have people give the agency to do so much more with like, you know, coding agents and these type of like app building software and so on. The really big part here is basically that like you need this code repository and you need to deploy it. Because this part of the testing means that you need an instance to get the most important parts, the logs. We need to see, like, when we're developing this button, can it actually do the things that we want to? Maybe it takes a little screenshot of it. It like looks through, like, does this actually work? So you need, like, for this specific feature, you know, you spin it off, you run it into Codex or Claude Code, and it kind of like does this and it tests everything along the way. But since we're so, you know, productive nowadays, you can't just do one feature, you need to have another feature. So like, you know, you can't just do like an improving the button for that. You also need to like, you know, create a new inbox for feature requests. This means that you need a new copy of the repo. And what does this tell us? Well, you could have this, like, you know, you could actually skip having a new repo and you can just use the same one. But you might actually have, like, let's say, like the button coincides with the changes you want to do for this new inbox feature, because maybe you're changing stuff in the similar, like, you know, areas of the code base. So if you want to do this a bit more pragmatically, similar like when you do at like enterprise deployment, same thing at like Amazon, is that you kind of do like branches or Git work trees, and you like, you know, do your feature development and then you try to merge it all into your main line and then you go from there. But what this means when we're talking about coding agents is that you can't just like have the copy of the rep, you need to also have like a copy of the deployment. And by copy of the app deployment, I'll just say, like, you know, for example, like a, let's say a Docker container where you can basically run this, because again, you need to have the logs, because otherwise it's like we can't test if it works. So this is kind of where it ties back to the CPU and the RAM and a little bit of storage. I don't think storage might, from my viewing of this, like all of these files might not be that much, but running an applications will require CPU and RAM. So if we go back to the full-blown assumption of like, well, it's going to be like a 1-to-1 ratio, I can't give you the answer to like that ratio. What I can tell you though is that GPU racks, I can't see an increase in CPUs to help power the GPUs. I might even argue on like a very like novice way of looking at how GPU servers seems to be set up, is that it might even be a lower future like number of CPUs per GPUs, because we make the CPUs utilizing their task allocation to the GPU more effectively. And on the agentic AI side, I can't see, for example, tool calling being a very heavy thing. Even if you scale this up to like millions of users, I can't see this being like, you know, the really big, powerful, like, you know, case for where CPUs come from. I think it kind of just has to boil down to the coding agents. Because again, like if you're going to be like as flashy as a YC, you know, startup founder or something, you can't just do one thing at a time. You need to do like, you know, all of the things, all of the time, continuously. And when you have this, let's say like, you know, your app is going to take a certain bit of RAM and a bit of storage. What happens is that like, you know, you might just need to have to migrate to the cloud. And when you migrate to the cloud, then you're starting to pay. You might pay per hour, you might pay per minute, you might pay per task, but like there will be something here that is going to need to require to spin something up for you to run this code repository and test things out. And depending on your app, you might require more or less, but no matter of those also, you will want to have, at least based on my experience when I worked at Amazon, if I'm doing, let's say like a forecasting model, let's say a huge transformer, to do some like time series predictions, you want to have some extra leeway on your dev desktop. You want to have like, so you don't choke it and then it's like breaks during a training run. So you would want, even during these instances when you're running these little code base like sandboxes to like run a new feature and develop it, you do want to have a little bit of leeway on the CPU and the RAM as well. Which means that like if you're running codecs in, let's say, the more cost-efficient non-fast mode, and the same thing with Claude Code, means that you're not only like just, paying for the tokens it's generating, but you're also needing to then start paying for the cloud instance to actually run that version of the app to validate that the feature is being tested and works correctly. So I can see that this might be like, good on like productivity, but I also will see that this will have a clear impact on cost. Because now you're not factoring in just only like the tokens to, do your regular Claude coding. You also need to factor in that you're going to spin up multiple things at the same time because you want to give more agency to your employees or users to do whatever they want. So yeah, this is kind of where I'm at the moment. I'm finding to the idea that like coding agents, yes. Like, let's say like agentic workflows, like for like research, I can't see on my testing that this is like the big, driver. And the same thing for like GPU racks. I can't see that. So this, if there's any point that I would encourage anyone who wants to dive deeper on this, is like going in further on the coding agents aspect. And my thesis is that like this depends on your app. You can have a small versus large app, which will translate to like, small versus large compute requirements per user / employee. And then it'll be dependent on, like how much safety do you want? Is it like really, critical that you don't have this break? Then, maybe you want to have a little bit of extra leeway when you do these things because you want to have even higher agency. But yeah, I'm at 12 minutes talking about this now. I could go on and on. I'll stop here. I'll let anyone who has any questions, feel free to ping me on the social medias that I'm on. Yeah, have a good one. I hope this was interesting to some people. Cheers.